What's up guys, Ryan Tech here. Today I'm going to be doing a video about launching and landing on different elevations. So we have this question and we want to figure out our horizontal distance, okay? So objective is to find the horizontal distance. Now our info is that, so this is our info, and we know that V initial is equal to 9 meters per second, our angle is 53 degrees, our delta y or sy is equal to negative 16 meters because 25 minus 9 is 16, and our acceleration in the y direction due to gravity is negative 9.8 meters per second squared, and there isn't any horizontal acceleration. And our objective, find the horizontal distance. So how do we do a question like this? Okay, so since we want the horizontal distance, or we have to write the kinematic formula, Sx is equal to Vx t, okay? Or you can write delta x is equal to Vx t, okay? So that's the first formula we need. Now, what do we have in this formula? What variables do we have to find? So we have Vx, okay, Vx is 90 cosine of theta, or in other words, 90 cosine of 53 degrees. But the thing is, why is it 90 cosine of 53 degrees? Well, if you check out Projectile on an Angle episode 1, I talk about how to figure out our Vx and Vy. So for now, pause the video right now and go on to that video and then come back. So we know that our Vx is 90 cosine of 53 degrees, but we don't know what our time is. So if we figure out our time, then we can figure out our horizontal distance. So which kinematic formula should we use? So if you don't know the kinematic formulas already, let me write them down real quick. So V final is equal to V initial plus AT. And our next one is V final squared is equal to V initial squared plus 2AD. Okay. So we immediately realize that this formula doesn't work because we don't have any time in it. Okay, so that formula doesn't work. Oh yeah, and we know that this formula doesn't work because we don't have our V final. Now let's see the next formula. V is equal to V initial t plus 1/2 AT squared. So far this formula does work. So I'll give it a check mark. Now let's see the next formula. The next formula is D is equal to V final minus V initial, and then all of that times T. Okay? And we immediately know that this doesn't work because we don't have V final. So we cross that out and we realize that this one is the formula that we're going to use. Okay? Okay, so let's rewrite it here. Delta y, or d, or sy, whatever you want to call it. So let's call it delta y is equal to v initial t plus 1/2 plus 1/2 AT squared. So now let's plug in everything other than t. So negative 16 is our delta y, and I should probably be doing this in a different color. So negative 16 is equal to delta y. So negative 16 is equal to 90 sine of 53 degrees. Because keep in mind we're doing this in the y direction, okay? So let me just write that right here. We're doing this in the y direction. Okay, so that means we are taking delta y, we are taking v initial y, we are taking acceleration in the y direction. That's what y direction means. So all of this we're doing in the y direction. Anyways, so now that we got that covered, let's continue. So our v initial y is 90 sine of 53 degrees, or speed times sine times theta, and then we're going to add that to 1/2 times negative 9.8 times t squared. Let's simplify this a little. So we can keep this as is. Now, let's try to form a quadratic here, okay? So to form a quadratic, we're going to move our constant term to the other side. So we're going to move our constant term to the other side. And by doing that, we first have to calculate this. So that's negative 4.9 t squared. And then we're going to say 90 sine of 53 degrees. And then all of that is equal to 0, and we say plus 16. Because we in fact moved this 16 to the other side, okay? Anyways, so now that we have that, we have a quadratic. Now you're like, hold up, it doesn't really look like it. Oh yeah, and sorry, this is 90 sine of 53 times t. Sorry, I forgot the t right there. So it's 90 sine of 53 times t, okay? So I forgot the t. My apologies, I forgot the t. Anyways, so now that we have that, okay, so it's t, and then it's, okay, so now let's rearrange this, okay? So we have 90 sine of 53 degrees times t minus 4.9 t squared plus 16 is equal to 0. Now, how do we rearrange this to put it in a good form? But what I mean by that is that let's just rearrange it. So we're gonna switch this term and we're gonna move it in front of this term, or behind that term, if I should say so. Anyways, so that's gonna leave us with negative 4.9 t squared plus 90 sine of 53 degrees plus 16, and all of that is equal to 0. Okay, so now that we have that, let's use the quadratic formula, okay? Now, if you don't know the quadratic formula, I'd recommend you look at a math video. But for now, I'm just going to give a short description of the quadratic formula. So the quadratic formula is ax squared plus bx equals 0 when x is equal to negative b plus or minus b squared minus 4ac, and then all of that over 2a. So let me write that down. So the quadratic formula is x is equal to, and it may be a bit of a handful to memorize, but with enough practice, it should come out of memory. Okay, so the formula is x is equal to negative b plus or minus radical b squared minus 4ac. Okay, and then we divide all of that by 2a. So that's the quadratic formula. Now in this case, x is t, okay? And in this case, a is negative 4.9, okay? And our b is 90 sine of 53, and this is supposed to be t here. And okay, so it's 90 sine of 53, and our constant term c is 16, okay? And this formula works when ax squared plus bx plus c is equal to 0, assuming that a is greater than 0. So this is a big thing to memorize. If you haven't memorized it yet, just watch a YouTube video. That would be my recommendation. I mean, after all, pause the video if you want to memorize it a little, but for now, let's continue. So now let's use the formula. The numbers are going to be t is equal to negative 90 sine of 53, and keep in mind there's no t. This is bx. X is equal to t, so this is bx, and b is 90 sine of 53, okay? Anyway, so t is equal to 90 sine of 53 degrees plus or minus radical, and then b squared. So my plus or minus symbol kind of looks a bit off. Here, I'll just read you. So sine of 53 plus or minus radical b squared. So 90 sine of 53 degrees squared. Then minus 4 times a, which is negative 4.9, times c, which is 16. C is our constant term. Anyways, and then we divide all of that by 2a, which is negative 9.8. Now, okay, we have two answers for t. One of our answers is going to be a negative answer, and one of our answers is going to be a positive answer. Now, we know that it's impossible to have negative elapsed time, which means that we have to use the plus or minus symbol that gives us a positive answer. So if you use the negative symbol, you'll get a positive answer, okay? And once you do this in your calculator, and make sure your calculator is in degree mode, okay? Or else this won't work. So if you calculate this, what you'll get is t is equal to 14.89 seconds, okay? So now we're basically all set. All we have to do is that plug in our t, and then we basically get the answer. So Sx is equal to Vx, which is 90 cosine of 53 degrees, times that, oops, and then we times it to 14.89, okay? And then our answer is going to be, drum roll please, our answer is going to be 806.5 meters. That is it for this video. Hope you enjoyed, and as always, have a nice day.